Hello class, it's Mr. Cablin here again, and I'm here to do an introduction to our brand new chapter, chapter 7, which will be dealing with angles. So, since it's an introduction, let's go through today's lesson here, and just I'm going to introduce you to some terms as well as some basic calculations that you will need to know how to do for the remainder of the chapter here. So this particular lesson is actually broken down to two short sections here. The first section just outlining some of the key words that you have been introduced before, but just do a quick refresher. And then the second half, we'll be looking at some of the calculations behind the basic calculations dealing with angles. Now, as you can see in the first screen over here, what we have to do here is to first identify what shape it is. If you say it's a triangle, by all means, you are absolutely correct. Now, most of you, if I asked you, what is the definition of a triangle? Most of you would probably say it's a shape with three sides. Okay, which is partially right, but if you break down the word triangle, what you have there is actually a shape with three angles. So I just wanted to show you again some definitions and how the words can come about. All right, so the first thing that I want to look at here again is just a quick warm up here. So as I said before, this is how many sides are there in a triangle? So we should know it's three. And for other shapes here, they also have some special names. For example, quadrilateral, okay, is a name for a four-sided figure. Okay, and last but not least, we have the pentagon, which is a five-sided figure, and so on and so forth. So that's just some basic terminology that I'm sure that most of you are familiar with. Now, another definition that we actually use quite often already in this course here is a right angle, and anything that deals with the right angle is 90 degrees. Now, some two other words here that are associated with right angles is when angles are greater than it, okay, or less than it. So an acute angle that is less than 90 degrees, okay, is called an acute angle. Okay, so an acute angle, like I said before, is any angle that is less than 90 degrees, and anything more than 90 degrees is called an obtuse angle. So if you take a look at the right-hand corner there, there's just a very basic example of which angle is acute and which one there is obtuse. All right, and a more comical version of that is something like this. As you can see, an acute angle, okay, it is smaller than 90 degrees, and obtuse angle is greater than 90 degrees. All right, so just a lighthearted way to approach that. All right, so some of the properties that we're going to look at in angle properties. First one here are called opposite angles. So when two lines meet, okay, the opposite angles or the angles directly across from each other are going to be exactly equal. All right, so that's just a property when two lines meet. Okay, and the first type of definition that I just want to mention to you here is what called supplementary angles. And basically this involves any straight line, one that goes straight across. So any straight line is going to be an example of supplementary angles where if you broke it up into two, both of the angles or two or more angles would add up to 180. So if you take a look at the example over here, we have the straight line going across, okay, and this line that cuts through it, okay, if I were to add angles A and B together, that would be a total of 180 degrees. Now, this particular relationship is going to come in very, very handy because supplementary angles are everywhere. So when you're looking at a problem where you have to solve for an unknown angle, see if there's any angles that will help you solve for that measurement by seeing its relationship to 180 degrees. So that's supplementary angles. Okay, another type of angle relationship is what's called complementary angles, and that's when two angles add up to 90 degrees. Okay, and as you can see in this diagram here on the bottom left-hand corner of that, where the two lines meet, okay, notice there's a little box there, which indicates that what you have there is indeed a right angle triangle. And when you have two or more angles within within that location there, if you add them up, they will all add up to 90 degrees. All right, so let's just see numerical examples just to tie in the properties and the numbers associated with it. So for the first one over here, let's take a look at what we have. So if you look at example A, you notice that we have two lines that meet, okay, and we have A and 73. So if you take a look at the angle properties, this is an example of opposite angles. And remember that what opposite angles are is that when you have two angles which are on opposite sides of each other, they're going to be the exact same measure. All right. Okay, this next one here for part B, notice with 123 degrees and angle B. So this here, when we add them together, add up to 180. So this is going to be an example of supplementary angles. Okay, so to set this up over here, I'm going to set this up algebraically. Now, some of you would probably know this as taking the angle and then subtracting it from 180. So that is true, but I do want to just show you how to set it up algebraically using definition here. So what I have here is angle B plus 123 degrees equals 180. And remember when we were doing algebraic techniques, okay, all you would do here, it was to take the number, which in this case there's a positive 123, move to the other side, then subtract it from the 180. Okay, and that's where most of you probably recognize this relationship. Okay, and then that angle B there is going to be 57 degrees. All right. Okay, and last but not least here, let's see an example of the calculation of complementary angles. So these two angles here, the A and the 43, they add up to 90. Okay, so what we have there, we would take the 43 and then subtract that from the 90 there. All right, so that angle for angle A there would have a measure of angle 47 degrees. Okay, so those are three basic angle properties that I just want to introduce you to. Again, main thing you have to see here, again, is just to know what the relationship is for those properties and then perform the algebra required in order for you to solve for the unknown measure. All right, so another thing I just want to go over again is just some form things that we have to see when we're dealing with angles and sides over here, and just simply the conventions of naming them. So to identify angles and polygons or angles involving parallel lines, we have to use three letters. So as you can see, what we have here is a right triangle pictured as angle ABC. Now, what's important when you're grouping and assigning angles with three letters, okay, the angle that you're looking at, okay, or the angle in question, which in this case here is the box, that will be the middle letter. Okay, so for example, if this was ACB, okay, that would be incorrect for this particular question because we're looking at the angle on the bottom left-hand corner. So whatever angle you are referencing here, that will always be in the middle letter when you're defining that particular angle. All right. Okay, so when we have a dot over here, it says the angle with the dot is angle XYZ. Okay, and mentioning to what I said just not too long ago here. Okay, notice what you have here is that the dot, which is located at the Y, the dot, when you're looking at the actual expression here of angle XYZ, you notice the Y is in the middle there. Okay, so I just anytime you're referencing an angle and you're using three letters, the letter with the angle is the middle letter. Okay, so if we the side of a triangle or polygon can be identified by the two vertices on the ends of the line segment here. So if I were to label a line segment using two letters, and I want to express it as one over here, okay, notice that I've labeled that as X, and X is the same thing as line segment AB. So again, there's just a couple conventions you can use when you are labeling the length of sides or labeling the sides in general. All right, so let's see an application of this here. It says use three letters to name the angle with a dot in each diagram. Okay, so if you take a look at example A here, we have the dot in an angle C there. So the way you express this, okay, is BCA or ACB, okay, depending which direction you're going. As long as the C is in the middle letter there, okay, you correctly identify the three letters here. Okay, now for part B over here, you notice that what we have here are two parallel lines going from left to right, and we have the dot where angle C is. Now the correct way to label this would be BCD. Now I'm saying BCD for this one because if you take a look at the direction again, okay, the arrow is going towards the uppercase D there. So when we're looking at the three letters, okay, you do have to put it in that direction, which in this case here is BCD. Okay, so just a little couple of rules here and there, depending on what kind of scenario you're given here. All right, so let's take a look at another one here. And in this diagram over here, we now have line segments that we've identified with the letter X here. So for the first one here, you notice that letter X, okay, is going to be line segment DF here. Okay, and this one over here, okay, this one here will be JK. All right. So again, just the way to label sides according to math convention, just to stay consistent. All right, so that's just a quick introduction to some terms here. So let's actually see a little bit more number crunching here. So we're now going to look at angles and the relationship when parallel lines are involved. Now, if you see this comic in front of you there, you notice this is the same one that I used in last chapter when we're dealing with parallel lines. And again, what we want to understand here is that when we have parallel lines, there is a relationship that deals with angles when we set them up accordingly. So what we have here, okay, are two parallel lines. As you know, we have two lines that are going from left to right there. And what we have here is that, and quite often you also have double arrows to indicate parallel lines that indicate that they're going the same direction. So these two lines over here, the ones going from left to right, they'll never meet because those are parallel lines there. Now, there are four relationships that we need to understand when we're dealing with parallel lines. Okay, first of all, parallel lines never cross. Okay, so we discussed that in the last chapter. And basically what we want to know here, okay, when something kind of transversal cuts through a pair of parallel lines here, there's going to be four patterns that exist between the angles, between the 8 letters that you see there. So we're going to go through each one specifically. Now, the first one that we're going to look at here is what's called the X pattern. Now, we saw this in the one of the beginning slides in today's lesson, and this is going to be dealing with opposite angles. So if you take a look at the two sets of parallel lines there, which I've outlined, which we have there, and the X pattern for the different parts of the picture there, okay, notice that the opposite angles will all be equal to each other. So where the X is, okay, and the ones that are directly across from it, they're going to be equal to that. Now, in particular, what I mean by that is if I look at angle A and F would be exactly the same, okay? And on that same location there, angle B and angle E will be the same. Okay, to the bottom of that, we have angle C and angle H, and angle D and angle G. So again, when you're looking at the X pattern, okay, and just like we did in the beginning of this lesson over here, when you have the opposite angles they're basically just directly opposite of each other there, they are going to be equal measures. All right, so that's the first pattern. Now, as you can see already, all these patterns are designated by letters, okay, because the way that you see them once we outline them are certain letters there, but they do have proper terms. So the next pattern here is what we call the Z pattern, which are formally named as alternate angles. Now, what this means here is that when you form a Z pattern, okay, the angles that are within that Z pattern are also going to be equal. Okay, so if you look at this diagram here, angle B and angle G will have the same measure. Okay, so that exists for the Z pattern. Now, to the opposite of that, it's kind of like an S, okay, but it's still a Z backwards, so to speak. We would have angle C and angle F to be equal. Okay, so that's dealing with the Z pattern or alternate angles. All right, the next one that we have here is the F pattern. It's actually going to be in several directions here. So for the first one here, we have an F that's upside down and backwards. And when you have this, okay, the angles that are part of the corner of that F there, those would be equal. So in this case here, angle A and angle C would have the same measure. Okay, now we're going to flip that around here. And you notice we have a backward F, and it's just downwards here. And then this would be angle B and angle D. Okay, so these would be corresponding, which means these two would be equal. Okay, and the next one here, we have another upside down F. This would be angle E and angle G would be the same. Okay, and last but not least over here, we have angle F and angle H. Okay, so we have noticed that we looked at 4 patterns there, but then the same relationships exist, that they're all going to be corresponding and equal. All right, the last pattern here are what are called co-interior angles, also known as a C pattern. Now, with co-interior angles, if you look at this C pattern, what you have here are the 2 angles inside that C pattern are going to add up to 180. Okay, so again, you see that 180 appear again, which we saw with the supplementary angle. So the calculations for an unknown angle are exactly the same. Okay, on the opposite side, we have the actual C pattern here. okay? And that would mean that F and G, when you add them together, would give us 180. All right, so again, those are the four patterns that we have when we see a transversal cutting through parallel lines. All right, let's see some numbers here. So for this one over here, just to start us off, now just to let you know, as you go through these calculations, you're going to see that once you have one measure, okay, you can pretty much solve for the other measures using different techniques. But I'm gonna approach this just using the information that's presented to us here. All right. So let's first take a look at A over here, and you notice angle A is located right there. Now, if you had to choose between the four patterns between uh, ZF, X, and C, okay, and you're looking at just the A and the 60 degrees here, okay, you should see that those two angles, in order for you to determine the measure there, you can actually solve using the Z pattern or alternate angles. Okay, so if you take a look at that, you'll notice that A and 60 degrees will be exactly the same. Okay, so that's how we did that measure. Okay, so now that we have that, okay, now that we know that A is 60 degrees, you can solve for B, C, and D using various methods and not just sticking to one. Okay, so just to let you know, there's more than one way to solve for that for different angles here. Okay, so for angle B, for example, okay, if we were to look at angle B and angle 60, okay, you should see that B and 60 are grouped together using the C pattern. All right. Now in this case over here, what we need to understand and remember is that B and 60, when you add them together, add up to 180. So to solve for angle B, all you would have to do is take the 60 and then subtract it from the 180. So we have a B there to be 120 degrees. All right. Now, another way you could have solved this is that we knew that A was 60 degrees from using the Z pattern from the previous example. You could have also used supplementary angles because A and B, when you add them together, also give you 180, which gives you the measure of the straight line here. Okay, so you would do the same type of calculation, but just using a different angle property. So just let you know, like I mentioned before, there's a couple of ways that you could solve that problem. All right. All right, so for angle C over here, now you notice that we now have two values, so you now have two or more different ways to solve for angle C and angle D. Now, like I said, I want to show you just how you can solve for this using just the patterns and the one piece of information that we have in this problem. So if you look at C and 60, okay, you should see the pattern that C and 60 forms there is the F pattern there. So when you're looking at the F pattern, this would tell us that C and 60 degrees, okay, would be, sorry, 60 degrees would be the measure for C there, all right? Okay, in an alternate ways, I'm gonna present again two other ways that you could have solved for this. Okay, we knew that A was 60 degrees from the first example there. Now using opposite angles or the X pattern, okay, we could have determined that C was also 60 degrees. We could have also solved for C using angle B, knowing that angle B was 120, and then C and B are the relationship between C and B is supplementary angles. All right, so like I said, there's a couple ways that you can solve for this. Now for angle D, you're going to use here, since we know the measure of angle B, okay, we could use the X pattern, okay, or opposite angles. So that tells us that D and B, okay, are the same. So what we have there is 120 degrees. All right. And again, you could also use A and C to solve for angle D by using supplementary angles. Okay, so like I said, notice that supplementary angles, okay, happens everywhere and quite often. Okay, when you're solving for the final angle, supplementary angles always comes in handy. So just a reminder when you're looking at at the problems after this lesson. All right, so those are the basic patterns when you're dealing with when a transversal cuts through parallel lines. So let's take a look at another example here. Now, for this one over here, you can see the parallel lines are located within a shape here. Now, the first thing we're going to do here is we're going to use F pattern to help us solve the problem first. Okay, and for this one over here, okay, when you're solving for A, if you take a look at A and 57 degrees and you look at the relationship between them, okay, you should see that A and 57 degrees, okay, form a straight line. Okay, so what you would have there between A and 57 degrees is the angle property using supplementary angles. To solve for angle A, all you would need to understand again is that A and 57, when you add them together, add up to 180. So to solve for A, we just need to take the 57 and subtract it from 180. So angle A will have a measure of 122 degrees. Okay, so again, you can see there, even though we use the F pattern, okay, we also saw that the relationships for one of the angles was supplementary there. All right, and last but not least, for part B over here, we can use the F pattern directly and see that angle B, okay, is an angle of 57 degrees of the same. So angle B would be 57 degrees. Okay, and that's just using the F pattern directly. All right, so you've just now seen two examples of parallel lines and the angle properties between them. So now for this one over here, this is a special example of a quadrilateral called a parallelogram, where you would have two opposite sides that are parallel to each other and the same measure. Now, the next thing that I'm going to show you here, okay, is going to be only applicable to parallelograms, okay? So it's not going to be for all quadrilaterals. So for angle A here, we're going to use a C pattern. And what you can see here is that when you're using the C pattern, remember that the two angles that make up the C pattern add up to 180. Okay, so we're going to take the 105, subtract that from 180. Okay, and that gives us an angle measure here of 75 degrees. Okay, and that would be for angle A. Okay, so for angle B over here, okay, what we can do for angle B and angle C, okay, is that only in parallelograms, I repeat, only in parallelograms are opposite angles equal to each other. That's why now once we have, in this case here, the given angle, which is 105 degrees, and angle A, which is 75. Okay, the opposite angles, which one, they're basically diagonally across from each other, they're going to be equal. So if we're looking at angle B over here, angle B would be 105 degrees. Okay, and angle A here would be 75 degrees. All right. So again, that's just a this what I just done for you there can only be done with parallelograms. All right. You're actually going to see this later on in this chapter as well. So you'll see this again. All right. Next one over here. Notice we have two parallel lines above and below, and what we have there inside them is a triangle, and that is a very specific type of triangle. Now you notice that what we have there is the fact that we have a triangle that happens to have two equal sides. Okay, so what we have there is an isosceles triangle. Now what you need to know about an isosceles triangle there is that not only do you have two equal sides, but two of those angles happen to be the same measure as well. Okay, so the first thing we're going to do here, let's solve for angle A. And as you can see here, angle A and 110 degrees, they form a straight line, so they add up to 180. So when we set this up here, okay, we have A plus 110. So all we're going to do here is take the 110, subtract it from 180, and A will have a measure of 70 degrees. All right, so we've got the first one. Now, as we go along here, okay, make sure that you're identifying the angle measure to each letter. You can write it like somewhere near it, so you can see exactly what you have, what you don't have. All right, so I said before, for angle B over here, what we have here is an isosceles triangle. And what you need to know about an isosceles triangle is that the angles directly across from the sides that happen to be the same, okay, are going to be equal. So what this means over here is that this angle A, okay, this and this side over here, this is what I mean by opposite sides. Okay, so when we're looking at this angle over here, okay, this is 70 degrees. So in an isosceles triangle here, okay, since this side here and this side here are the same, that means these two angles would also be the same. So B, okay, would be the same as A. All right, so we've taken care of angle B and angle A. Now we need to take care of angle C here. Now what you need to know about inside the triangle is that all three angles add up to 180. So to solve for angle C over here, okay, we have to add up those two angles and then subtract it from 180. Okay, and the way we do that, I'm just setting this up algebraically here. So we're going to take the two 70s, okay, add them together, and that'll give me 140. And then from there, we're going to subtract the 140 from 180. Okay, so angle C will give us 40 degrees here. All right. So what we have now are three measures, and we now need to solve for angle D and angle E over here. Okay. Now at this point over here, you could use several different methods in order to solve for those angles. Well, I like to choose the most direct way to do it. So for angle D over here, if you look around, okay, you notice that you probably want to look for a pattern for you to solve for angle D using the measurements that you've already solved for. So the best way to do this is to use the Z pattern. Okay, so when you see the Z pattern here, that tells us that D and B, okay, are alternate angles which happen to have the same measure. So since angle D and angle B are the same, okay, angle D would be 70 degrees. And again, this particular relationship, again, only exists for the fact that the two lines above and below the triangle happen to be parallel, okay? All right, so that's the last one there. Okay, and for angle E over here, there's actually two ways you can solve for this. Actually, three ways. But like I said, I want to use the most direct way to solve for it using the information that we already have. So um, if you take a look at the original information that's given to us in the question, we only had 110 degrees to work with. So if you take a look at angle E over here and the 110, those two angles are grouped together using the C pattern there. So from there, all we'd have to do here is understand that E and 110, when you add them together, give us 180. So we take the 110, subtract it from 180, and that gives us a measure here of 70 degrees there. All right. Okay, so that's one option. Okay, a second option that you could have done is you could have also have used the Z pattern and see that E and A are alternate angles, and E and A would be the same. As you can see it right there, they are. Okay, another way you could have done it is that if you take a look at the very top part of this diagram, you should notice that D, angle C, and angle E all form a straight line. So an alternate way you could have done this here is understand that angle D, angle C, and angle E would add up to 180. So what you would do there is add up the two angles that you already had. Okay, the 70 degrees and the 40 degrees, add them together, subtract it from 180, and guess what? You would get the 70 as well. So once you have two or more angles in a problem, you have various options to solve for the measures of the other angles there. All right. All right. So if you turn the page in your package there, okay, you'll see there's a bunch of practice questions for you to practice on dealing with the basic properties of angles. Okay, and in the next lesson, we'll start looking at the shapes and the angles within the shapes there. So I will see you in the next one.